Okay, let's do one more example before we finish with chapter 8. So this is under 8.4, and I'm only covering 8.4.4 if you recall. So this was an example. This was an exam problem from 2019 spring. It says consider the free response of a second order underdamped system. Of course, it has to be underdamped. Why? Because you can see it's oscillating. So now, what do I want? What is the logarithmic decrement and damping ratio? So logarithmic decrement. Do you recall what that is? The logarithmic decrement. What was the variable? We use delta. Okay, delta equals the natural log of the two consecutive peak. Okay, so this was like peak value. I think I was using b. So if this was your b1, okay, y value, right? The height. Okay, so this is b2. This is b3. Okay. And so on. So this was b1 over b2. Okay? In an exponentially decaying function, this delta should be the same, right? For a different set of consecutive peak. So b2 divided by b3, that should be, I meant to say 3. Okay? That must be also delta. Okay? And so on, right? So let's think about this. You have a delta. So let me just write it separately. So here, let me write E. And then delta is also equal to this. And delta equals natural log of B3 to B4 and so on. Okay? So we have, this is B1, B2, the peak number 1, peak number 2, peak 3, 4, 5, 6. Okay? So I have 6, 1. B5 to B6. Okay, I think I just had to write down one more. Okay, let me do that right there. Okay, and delta is also equal to B4. Okay, I'll write it here. So I have delta is natural log of B4 over B5. Okay, they're all deltas. They're all the same. Okay, so if you if you add, okay, how many? 1, 2, 3, 4, 5 deltas. What do you have? You have natural log of B1 over B2 plus natural log of B2 over B3. Can I put that? The last one, natural log of B5 over B6. Okay, and then do you remember what the rule is? If you want to add a logarithmic function, because so this can be simplified as natural log of b1 over b2. What does addition become? Multiplication, right? So you have a b2 over b3 times and b5 over b6. Do you know what I'm getting to? Okay, b2, b3, they all cancel out. And what do you have? You have natural log of b1 over b6. Is that right? Okay, so that number is given. So this is 5 times delta. Okay, 5 times delta equals natural log of b1, which is, okay, be careful to make sure that you read the right one. What's 0.3056? That's the x value or the y value? That's x, right? So what's the height? The initial height is 2.9582, 2.9582, and divide by natural log of that looks to be 1.06, 1.0617. Okay, so now delta equals, so let me see if I can do this. Okay, so how do I clear? Clear? Okay, I don't see clear. So, okay, so let's see. What did I have to do? So this one is 2.9582. Okay, this is a reverse Polish notation calculator. So you have to do enter first. And you go 1.0617. And you have to put in divide. Okay, so it divided two numbers. Okay, so that's 2.7863 is the ratio of the two. And let me see if it's going to work. Natural log of it. Okay, so 1.0247. And what you have to do, you have to go 5 and you go divide. Okay, so I find delta to be 0.2049. You better check this with your own calculator. Yep. Okay, so now what else do I need to do? Let me go back to the original screen. Okay, so that's a logarithmic decrement. So I found one, 0.2049. So now, do you remember how do you go to zeta? Okay, I can go back to the old lecture. What did I say zeta was? It zeta equals to, here it is. Okay, here it is. Can you memorize that? Delta divided by square root of 4 pi squared plus delta square. I think I can barely remember that one. So let's see. Okay, here it is. So zeta equals to absolute value of delta divided by square root of 4 pi squared plus delta square. Okay, so should we try this again? I'm really enjoying this. I love this. Okay, so delta was 0.2049. What you go is, I'm just going to do enter. Okay, enter. And you go 4, enter. I'm not sure if I can do this. 3.14. How do I square it? Square. Okay. And you go times to multiply those two numbers. Okay. And you go, what was delta? 0.2049 squared. And you have to add them together and take a square root. Okay. And you divide from the original one. So this is, I'm going to have to write this down because I'm not sure about this. 0.2049 divided by, I think this is 6.2833. Whew. Is that right? I better do this in my head. So pi is about 3,936. And delta is a small number. Oh, amazing. I think it's right. Okay. So how do you get the zeta? You just go divide. Ha. Okay. So you get zeta is about 0.0326. Okay. After the video, I'm going to check whether I did everything right. If I didn't, I'll just remake the video. So here it is. I'm going to go to delta. The zeta equals 0.0326. So neither one of them has a unit. Okay, so this is a damping ratio. Damping ratio zeta equals this. And the logarithmic decrement delta is 0.2049. Okay, it looks like it. It looks to be lightly damped. So now the second part of the question says, what is the damped natural frequency and the natural frequency? Damped natural frequency, omega d, that's 2 pi over the period. Okay? So let's see. I need to figure out the period. So now I'm going to go from here to here. How many cycles do I have? 1, 2, 3, 4, 5 cycles, right? 5 cycles. So the total period is, okay, so total period is, where a period is equal to 1/5. Okay, 1/5 of 8.5798. Do you see it? Do you see? 8.5798. 8. Oh boy, 8.5798. Oh boy, can't remember any of these numbers. Okay, what's the T1? 0.3056. 0.3056. Okay, you wanna watch me do the RPN calculator again? Ooh, I'm really liking this RPN calculator. Okay, so what does it say? So I go 8.5798, go enter. Okay, 0.3056. Okay, you want to subtract, right? Minus, you subtracted correctly. Okay, and then what you do is you go 5 and divide. Okay, I'm just liking this too much. So that's 1.6548 seconds, and therefore omega d is, oh, how do I do this? Okay, enter. Okay, and then I'm going to divide that number by 2 pi and invert the whole thing. Or should I just go 1 over that? 1 over that. Okay, that's good enough. And enter. Okay, so I guess y means that you're just saving that number for some other operation. So what is that? Oh God, I can't remember what that is. Oh, that's 1 over t. Okay, that's 1 over t. And then you multiply by 2 times, okay, and then pi. What is pi? I think I'm going to just put that in 3.14. Okay, and you multiply. Here it is. So that's 3.7969. Or can we just keep three significant figures? 7, how about 80 radians per second? And this is 1.65 second. Okay, so now I want to find the natural frequency. So omega n equals, how does it go? It's omega t divided by 1 minus zeta squared. Okay, ooh, should we try this one? Okay, so now I'm going to say enter. Okay, I'm saving that away. And now I'm going to calculate the 1 minus zeta squared. Whew. Okay, so 1, enter, zeta squared 0.0326 squared. Okay, and minus, I think I need a square of the whole thing. And then invert it. Okay, and you multiply by the omega d, which is y there, right? And you multiply. Here it is. So that's equal to 3.798. It's a very lightly damped system. It's about the same. Okay, 3.8-ish again. Okay, radians per second. It's all because your damping ratio is so tiny. So this ends This is the last lecture of chapter 8. So depending on how it goes, I may have another lecture to help you with the homework, or I might put that on OneNote. Okay, and we'll move on to chapter 9 next week. Okay, thank you.